In this tutorial video, we will work with crack growth. But instead of a straight line crack growth, we will force the stress field to be a non-pure mode 1 stress field, so the crack will bend and XdTd will have to find the proper direction of crack growth. So I have here already our panel with the traction load applied to the top boundary and displacements in the y direction constrained in the lower boundary. I have also applied a displacement boundary condition to this vertex here so that there is no movement in the x direction. With that, we have our loads applied and our sheet has constrained rigid body movements. First thing I have to do is to define my crack. In this case, I want to create an edge crack starting from this vertex here. In XdTd, edge cracks as boundary conditions are associated to the geometry. So I right-click with the left mouse button here to select the vertex, right-click to bring up the vertex context menu, and I have the option here to add an edge crack. I select it. I have to reduce the initial size here to 6 millimeters. And there we have our crack defined here. In order to disturb the stress field, we will add a few holes in this structure. So I will more or less here select the external boundary, right-click to bring the menu, and add an internal boundary. We will add a circular internal boundary. The position here I will correct. It's going to be minus 30 and 10 with the radius of 5. So I apply this, there is where it has to be, and accept. I will now copy this hold and paste it in other places. So I select it, come here to the menu on the right and choose copy, and then paste. So the first place I will paste is at minus 10, minus 10. Which is here. So I accept this. Then I paste it again. Now at plus 10, plus 10. And now again at plus 30 minus 10. And that it is. Now we have our complete geometry. And you see that these holes, they create shadows where as the crack gets into them, it will have to change direction. Okay. So how do we run this crack propagation analysis? We just come here, select run. We want to perform a crack growth analysis. What I will do here, I will select that I want the crack to grow up to 50 millimeters, and I want it to do that in 50 steps. And the main point here is that I have to uncheck this option. This option, it tells XdTd, don't worry about direction of crack growth, it will grow in a straight line. But in this case, we have to unselect this because we know it's going to grow in a different direction. With that, we just click run the analysis, and it starts to run. You see that sometimes it goes slower because it's trying to converge and finding the proper direction of crack growth. It finished with 78%. It means that it did not require those 50 steps that I determined to get to the final end. So let's see, where did we get? To see that, I just select here, go to result, crack growth, and choose growth path. And then we can see here how the crack has grown. You see that it's pretty fast that XdTd performs this analysis, and this case is actually one of the benchmark cases. It has been verified against ANSYS, and it reproduces perfectly the results. In order to see if it is really correct, one of the things that we can do is just to look at the stress intensity factors, because we know that the crack growth has to try to minimize K2, right? So the plot here we have is for K1. I will just come here and I will add K2 so that we can see its value. And we can see that it is basically zero throughout. Well, the crack changes direction. There is some small oscillation here, right? But it is basically doing what it was supposed to do, which is to choose the direction of growth, which minimizes K2. And that's it. With this, we conclude this tutorial video. Thanks for watching.